Hey YouTubers, what up Islanders? Welcome to zEyeland. It's your boy B-Boy Apps, and today I'm covering the highlights of zEyeland's latest project. So look alive because I'm about to break it down. Introducing Clovis. Clovis is easy to use and supports multiple connections. To access your Clovis application, just head over to its assigned address on the nearest web. Once your session has been loaded, the Clovis app offers a few modes to control over your robot's peripherals. The arrows on the left side control the robot movement. The arrows on the right side control the camera angles. On the top left are adjustable gauges that allow you to change the amount of real rotation per cycle. Next are the four switchable modes: snapshot, stream, record, and compression. The Clovis LED indicator tracks the phases. Red indicates video is being recorded. Blue indicates video compression is taking place. So be tempted not to access other modes during this process. The LED light will switch to clear when the computational process is complete. The refresh symbol represents stream mode. It refires the stream script and is good for spying. Use the custom stream address and had a whole crew spying too with the widescreen view. Oops, what happened there? Oh, that's just the beta feature of Clovis. Clovis plots objects onto his radar graph when he's self-driving. Configure an ultrasonic sensor to try it out. Alright guys, so instead of showing you how to configure an ultrasonic sensor, I'm going to log into my Raspberry Pi robot and show you some code. So PM2 is the process I'm using to automate my Node.js application and run it on boot up every time. I'm going to go into the main Clovis application and show you what the code looks like. So this is my Clovis server, and here's my Clovis application. Not too difficult to understand as all the packages that I'm requiring. I'm using GPIO library to control the Raspberry Pi's GPIO pins. Pretty much setting all the pins right here from the LED to the servos to the motors. Some simple API configurations. Depending on what address you come in, you might render different versions of the application, whether that's the control screen or the widescreen just for only viewing. I have my socket IO that's pretty much communicating between the client HTML page and the server that you're looking at now, and sending different commands back and forth so you can control the peripherals on Clovis. The main takeaway out of all this socket is when you're switching between modes, you're using this terminate package to identify the PID number so you can cancel those processes. Since I'm only running on a gigabyte of RAM, we want to make sure we're cleaning up after ourselves. One of the neatest things about this project is I am using another socket server to take the information I'm processing from those video scripts to send it to a HTML page canvas so pretty much I'm taking that encoded data and presenting it in a way that the canvas can read it. This is all done due to a developer who made a application called JSmpeg. So shout out to him. I kind of extracted the code I needed to run that. This is where I'm setting the different bash scripts to fire off depending on which modes you activate. And then right here is where I'm setting the name of those files because it's uploading it all to a server that I can download. I'll kind of show you more of that. So these different scripts right here is four bash scripts. This is the main script if you want to take a picture, if you want to record, and then whenever you're done recording, it compresses it and saves it all into the server. And I'll kind of show you what that looks like too. Yeah, so inside this public folder, if I go inside of recordings, I'll get a list of everything that I've recorded. You can see I got 3 videos in here. These are all compressed, like 100 megabytes. Super cool. Without compressing, I get like a 1 gigabyte, and then next thing you know, my robot is freezing because it's out of storage. So last thing I'll show you, also have another folder here called Basic Pro, and this controls all the security features of Clovis. So he has this script called detect motion. This one's a Python script, and pretty much it allows Clovis just to sit idle and not record anything. And whenever he detects motion, he'll instantly start to record, and then he'll notify me and send me an inbox. So It's actually pretty cool script right there. zEyeland interrupts this program to bring you the highbrow mind behind this intuitive machine. Professor Shalabalalava. Thank you. Allow me to introduce Clovis. Clovis's stack consists of a multitude of different components. Here's a breakdown of some of the more essential parts that assist in Manifest Destiny. The chassis is the fundamental foundation of this bot. It's arguably the most important part. So measure all dimensions well to prevent from looking trash. The Raspberry Pi, the brain behind Clovis. In spite of the shared 1 GB of RAM, the Raspberry Pi provides real-world performance. It has wireless NIC and an integrated RJ45. The Raspberry Pi can be operated from various ways and great for controlling peripherals and GPIO support. Custom software. The software ranges over a variety of languages, including Node.js and Python apps. The most convoluted application Clovis houses is perhaps its facial recognition software, which depends heavily on opencv. Oh, my favorite, the Pi prototype hat. The hat prevents the usage of having to use a breadboard. The H-bridge. The L298N chip switches the polarity of a voltage, often used in applications that require DC motors to run forward and backwards. The HDMI touchscreen is plug and play. It makes Clovis debug friendly. Alright Islanders, that's it for this episode of zEyeland. Hope you guys enjoyed those facts I just spit. If you didn't learn anything, then comment sardines in the comment section and I'll send you an Amazon link to purchase some Q-tips to clean your ears, cause I'm a YouTube freshman. It's apps and I'm out of here. Enjoy this dance outro.